Welcome again guys sa subject natin, Physics for Engineers. And today we will start our discussion for the final phase. Okay? So, konting ano na lang, konting tiis. Okay? So, nasa final part na tayo ng course natin. So, yung final phase natin again is about electrical engineering. Okay? So, for today, yung lesson natin is about basic electrical engineering. So, yung mga concepts involved regarding basic electrical engineering will be discussed, and some notations or symbols later will be the same as nung nagamit natin sa thermodynamics o yung sa semifinals natin, pero you should not be confused with that kasi for this lesson or for this um, phase, more on electrical engineering yung pag-uusapan natin. Okay? So at the end of the session, these are the things that hopefully you will be able to take take outs, no? Yung magiging take outs for this lesson. Okay? First one is yung ability to understand yung principles ng electricity and together with the concept and theorem about electricity. Next is to apply yung Coulomb's law. So later we will be defining what is Coulomb's law and apply it in solving problems, engineering problems. And last is to solve problems involving voltage, current, and resistance. So kung ano yung difference nung bawat component na yan, we will be discussing it one by one. Then by next meeting, we will be correlating them with each other. Pero for now, we will just be discussing them independently, and we will try to differentiate kung ano yung difference ng one component from the other. Okay? So let's start. So let us start with the smallest unit um, ng matter natin, ng ano no, physical system, which is yung atoms. Okay? So all matter is made up of atoms. So sabi atoms daw is the building blocks of matter. Okay? So when we are talking about atoms, as we have already discussed, as we have already know siguro from our previous subjects sa chemistry during high school, okay? So it is composed of this part. So we have yung protons and neutrons, and pag yung place o yung bubble na kasama ang proton and neutron, tawag natin doon is nucleus. Then um, yung the one surrounding the nucleus, itatawag nating electrons. So with these components, these are the subatomic particles na nagme-make up ng atom natin. Okay? So there are two basic components in every atom. So yun nga, yung nucleus, which is composed of proton and neutron natin, and electron cloud, which is doon nagpo-flow yung ating electrons. Okay? Then, yan. So, yung mga subatomic particle natin is may mga charges siya. Tatawag natin electric charge. So, pag si proton, siya is positively charged. Si neutron is no charge or neutral siya. And then si electron is negatively charged. Okay? So meaning, kapag nagkakameron ng sharing of charges ang dalawang particle, um, ang nag-transfer lang, okay? Ang nagta-transfer from one atom to another, one particle to another is sa electron lang. Okay? So, ibig sabihin, parang katulad lang din sa heat energy natin na kailangan mag-balance out lahat yung mga magkakatabing atom natin hanggang ma-attain nila equilibrium. So same din sa electricity. Okay? So kung halimbawa meron tayong isang particle na negatively charged, no? So ibig sabihin pag negatively charged siya, so ibig sabihin pwedeng may excessive na number ng electrons sa atom niya. Kaya siya negatively charged. So siya capable siyang mag-transfer ng electron to a particle na lacking an electron. So kapag nag-meet sila, or halimbawa positively charged yung isa, ibig sabihin mas madami yung number ng proton, mangyayari is isa-share or mag-a-attract sila and isa-share ni electron yung yung particle na negatively charged, share niya yung electron niya to the particle who is positively charged to equilibrate yung particle in both yung number ng protons and yung number ng electrons in both particles. Okay? And then, yung simplest form of matter natin is yung elements. Okay? So, kung matatandaan natin sa periodic table natin, listed is yung lahat ng elements na makikita natin sa Earth. So, continuously updating siya, no? As human continue to discover new elements. Pero each element has information about dun sa atomic structure niya. So lagi siyang merong atomic number, atomic weight, no? Na yun yung nagde-describe kung ano yung pinopossess na characteristic in atomic um, level nung bawat elements na to. Okay? So may number yan ng proton and electrons, no? May particular number ng protons and electrons na naka-indicate din dun sa periodic table natin. Okay? So, ito lang, more on a clear picture lang nung diniscuss natin kanina. Again, nucleus yung certain portion, yung center portion ng atom natin, which is composed of the proton and neutron. And then we have yung electron natin, which is floating around the electron cloud, no? Or yung mga negatively charged atomic particle natin. Okay? Again, si proton is positively charged and si neutron is zero or neutral. Okay? And then we come now to define what is electricity. So, pag tinawag natin electricity, it deals with electrical charges in motion. Okay? So, electrons have negative charge measured in coulombs. So, yun yung unit niya, coulombs. So, when electrical and magnetic forces move electrons from one atom to another, an electrical current is formed. Okay? So later, i-discuss natin kung ano yung um, relationship ng current sa charge and sa time. No? Okay? And then we have yung electrical charge. Nasa symbol na ginagamit, electric charge is given the symbol capital Q or small q, which is the same as yung sa notation natin sa heat, no? Pero as I've said earlier, we should not be confused with it kasi for this phase or this final part ng ating course, we will now just be focusing on electrical engineering. So yung Q or yung small q is representing yung electric charge ng particle natin. Okay? Then electrons are the charges carriers that flow in an electrical circuit. So later de-define natin kung anong ibig sabihin ng electrical circuit. So ibig sabihin niya, yung flow ng charge natin is from negative to positive terminals. Okay? Then electric charge is measured in coulombs. Okay, so yun yung tawag dun sa unit niya given the symbol C. Okay? And then si electric charge, may value, may constant value si proton and si electron na 1.6 times 10 to the negative 19 C. Okay? So, same size lang silang dalawa and ito yung um, constant value niya. Okay? So, you have to take note of this one. Next, yung charge interaction natin. So, if two particles are the same ng yung charge nila or positively charged siya or negatively charged sila parehas, their tendency is to repel each other kasi they will no longer benefit from each other, no? So kung positively charged na yung particle, tapos malapit siya sa isang positively charged din, wala nang, ang goal is to receive, no? To receive additional electrons from one particle. From one article. So from one particle. So kung ang particle natin is same nagdalak ng electron, tendency niya is to repel and to attract to particles na may negatively charged, no? Same as din no sa mga particles natin na negatively charged nga siya. So parehas silang yung parehas ng particle natin is have excessive number of electrons. Pero hindi nila ma-share with each other kasi they're already in balance na or sobra na yung laman nila. So, what they tend to do is to look for particles who are positively charged. Kaya pag nakita sila, no? Yeah, same with the battery, no? Same yung concept nito with the battery. Okay? Then kaya sa magnet, no? So, ngayon pag opposite na yung ano natin, yung charge natin, we have positively charged, negatively charged. Okay? Tendency nila is to attract each other kasi si negatively charged na particle, pwede na siya mag-share ngayon dun sa positively charged. Okay? So, doon nagkakameron ng sharing ng electricity. Okay? Next. Okay. Hello. Yan. Delay. So, let's now introduce yung tatawag nating Coulomb's law. So, sinasabi lang nung law na to na yung electrical force between two charged object daw is directly proportional do sa product nung quantity ng charge ng object and inversely proportional dun sa square ng separation distance between two objects. So, ibig sabihin lang niya, kung gusto natin makuha yung electrical force, sabihin natin F, yung tawag sa kanya, no? Makukuha daw natin siya by getting siya ay directly proportional sa quantity of charge, no? Yung charge natin dito is Q1 and Q2. So product ng quantity ng charge. So product ng Q1 and Q2 and then inversely proportional sa square ng separation distance. So ang separation distance niya is itong D na to. Okay? So yung distance ng two particle with each other. So inversely proportional, so nasa denominator na siya. Then nakalagay is naka-square dapat siya. So D squared. Okay? So kapag meron tayong proportionality na ganito, to to change it into efficient form, mag-introduce tayo ngayon ng constant of proportionality. Ang tatawag natin K na itong K na to, meron niyang definition. Okay? So yung definition niya is ito. Si K daw na yon is yung Coulomb constant na tinatawag natin. Okay? So yun yung according to Coulomb's law, yun yung relationship ng force dun sa charges and distances natin. Okay? Then we have a constant value for Coulomb constant. That is 9 times 10 to the 9 Newton meter squared per Coulomb squared. No? Hindi yan Celsius. No? So be mindful of that. Baka akalain nyo Celsius yung sa ilalim. No? That is Coulomb. Okay? Then Q1 is a charge of mass, Q2 is charge of mass 2. Then yung R, kanina D yung nakalagay pero same lang naman. So may ibang textbook, iba lang yung notation pero same lang naman yung dinidiscuss. So R or D, basta yung denominator natin na naka-square ang value is always the distance between the two particles. Okay? And then yung mga calculate natin electric force, uh, isa sinasabing much stronger than the gravitational force. Okay? Kasi kung hindi siya mas stronger than sa gravitational force natin, baka hindi magkameron ng sharing of flow ng electricity, no? Kaya kailangan mas greater than siya sa gravitational force natin. Okay? So, let us now apply yung Coulomb's law sa sample problems so that we can appreciate kung ano yung ibig sabihin o paano gamitin yung Coulomb's law. Okay? So, let's have our first example. So, let's say we have two particles each with a charge of 3 microcoulomb. Okay? Placed 50 centimeter apart. Question is, determine the electric force between the two particles. Okay. So, in solving this kind of problem, the first thing you need to do is to convert muna into the same units yung lahat nung given natin. Okay? So, again, our formula is F is equals to K, Q1, Q2 over R squared. Okay? So, tapos alam natin na yung K natin is equals to 9.0 times 10 to the 9 Newton meter squared over Coulomb squared. So makikita nyo dito, doon sa K natin, ang distance natin is naka-meter. No? Then si charge natin is naka-coulomb. Okay? So what we are going to do first is to convert yung column natin, yung micro column natin, convert to coulomb. Then yung centimeter na distance natin, convert natin sa meter. Okay? When we say micro, so ano yung scientific notation for micro? If anybody can recall, ano yung ano natin? Okay? So, thank you Mr. Pagkatipunan. So, micro, ibig sabihin 1 times 10 to the negative 6. So, itong sa left side, tawagin natin Q1, equals yan sa 3 times 10 to the negative 6 column. Okay? So, same as doon sa Q2 natin, siya ay 3 times 10 to the negative 6 column. Okay? Then, we have our distance, 50 centimeter. So, in meters, okay, this is equals to 0.5 meters. Okay? Kasi 1 meter is equals to 100 centimeter. Okay? So, now na-convert na natin into one single unit yung value natin, we can now determine the electrical force, no? So, direct substitution lang siya sa equation natin. So, 9 times 10 to the 9 Newton meter squared over Coulomb squared times 3 times 10 to the negative 6 Coulomb. Then, squared ko na lang kasi parehas lang naman yung value, no? Then, over distance natin na 0.5 meter squared. Okay? So, yung meter natin naka-squared, so cancel out. Yung columns natin naka-squared, so magka-cancel out. Matitirang value natin is in newtons. Okay? So, ano po yung value nito? Anybody? Okay, Mr. Perino, 0.16. Okay, check natin ha. So, please try to input sa calc, no, para nakakasunod tayo. Baka mamaya, meron pa din hindi marunong mag-type sa calculator. Kawawa naman. No? Para tulungan natin. Okay, so should be, so naka-squared yung ilalim, no? Baka hindi na squared nung iba. So the correct answer is, okay, so correct Miss Revillosa, no? 0.324. Okay? Tama. Times 10 to the 6, 2.5. Okay. So this should be 0.324. Okay? So, ito yung answer natin for number 1 o yung electric force required. Okay? Ito yung force between this article. Okay? Question or clarification regarding the first example? Wala ba? Oo. Kung clear, kahit thumbs up lang, kahit thumbs up. Kung clear naman, okay naman, no? Para alam ko lang na may ka-interaction ako. Okay, thank you. Next, okay, so number 2. So we have a point charge ng Q is equals to 4 micro coulomb. 3 centimeter apart daw siya sa charge Q prime, which is 1 micro coulomb. Okay, first question is, find the magnitude of the Coulomb force. And exert ng one particle to the other. And we have to identify kung attractive or repulsive yung force natin. Okay, first one. Okay, so convert muna natin. So si Q1 na lang yung left side. Magiging 4 times 10 to the negative 6 Coulomb. And si Q2 will be 1 times 10 to the negative 6 Coulomb. Okay? Then si 3 cm will be 0.03 meters. Okay? So using the same formula sa previous example, okay, makukuha natin yung value ni F times 10 to the 9 Newton meter squared Coulomb squared. Then we have 4 times 10 to the negative 6 Coulomb. times 1 times 10 to the negative 6 Coulomb all over yung distance natin na 0.03 meter squared. Okay? So, naka-squared yung meter, naka-squared yung Coulomb. So, yung force natin is equals to, so ilan? 0.03 squared. Okay? So, thank you do sa mga nagsosolve, no? So, we have 40.0 Newton. Okay? So, ito yung sagot natin for question number 1. So, tapos sa letter B, ano yung force natin? Attractive or repulsive? Pati
Repulsive.
repulsive, sabi ni Mr. Romano. Okay? So, correct no repulsive kasi yung given particle charge natin are both positive. No? Okay? So, repulsive force po yung atin. Ibig sabihin, ang gagawin ng dalawa, pag nag-meet sila, ipupush nila yung isa't isa ng 40 newtons palayo with each other. No? Talagang iuudyok nila yung isa-isa. 40 newtons apart. Okay? Okay tayo sa problem 2. Okay, thank you. Next, sample 3. Okay, we have two balloons with charges 3.37 microcoulomb and 8.21 microcoulomb. Nag-attract each other with a force of 0.0626 Newton. Question is determine the separation distance between the two balloons. Okay? So, question regarding this problem, hindi naka-indicate na kung alin do sa charge yung positive or negative natin, no? Pero sinabi naman sa problem na nag-attract sila with each other, no? So, huwag na natin i-contest na para sa mga positive yung given, no? Kumbaga, in-state na sa problem na nag-attract with each other sila. So, ibig sabihin, yung kina-calculate natin, yung given force natin is an attractive force. Okay? So, given sa atin, si Q1 is equals to 3.37. Convert na natin coulombs, no? Q2 is 8.21 times 10 to the negative 6 coulombs. Then yung force natin is 0.0626 Newton. Okay? So, basically, i-derive lang natin yung formula in terms ng radius natin, no? So, this will be r squared k q1 q2 over f. Then we have to square root both sides. So, we have r is equals to k q1 q2 over f then square root. Okay? So, i-substitute lang natin yung value ng given natin. We have 9.0 Newton meter, times 10 to the 9 Newton meter squared, Coulomb squared, times 3.37 times 10 to the negative 6 Coulomb. Tapos, times pa ulit to. Wait, ayusin natin para magkasya. Okay, so we have 8.21 times 10 to the negative 6 Coulomb all over yung force natin 0.0626 Newton, then square root natin. Okay? Then cancel yung Coulomb then yung Newton, matitira is meter squared, then square root, matitira is meter. Okay? So, okay, may mga nakita naman ako nag-solve na. Okay? Nasobra ka lang miss author ng decimal, no? So, it should be 1.994. Okay? So, 9 to the 9, 3.37, negative 6, 8.21, negative 6, divided with 0.0626. And square root is 1.994. Okay? So, okay na yan. 3 digit or baka sa choices, baka meron pa sa choices na ng 2.0 meter, no? Okay? So, depende sa choices, sa multiple choice exam, if ever multiple choice yung problem. Pero, 2 decimal, 3 decimal, 4 decimal, or to the nearest whole number can be accepted. No? Okay? Okay, I think wala pa naman so far, no? Na question. So yung mga example natin for today, halos ganito lang na base lang dun sa formula, no? On our session next week, I'll try to give yung more in-depth example kasi masyadong child play na tong ginagawa natin eh. So, hindi siya pang college level, no? So, since you're a college student now, we have to um, figure out kung paano natin gagamitin yung engineering judgment natin. Okay? So for now, ito. So I guess lahat naman naiintindihan yung ano natin ngayon. Okay? Kasi baka mamaya magulat kayo sa exam. Ba't ganun na naman ang binigay ni Sir? Out of this world na naman. Okay? Kasi before I get that, I always get that na sabi, parang ang hirap daw nung binibigay. Pero as much as possible, nakabase lang lagi sa concept yung binibigay kong example. No? Ang kailangan lang is i-analyze mo lang siya. Kasi yun yung kailangan ma-build sa inyo, yung analysis as future engineers. Okay? Sample number 4. Okay? So distance between two identical charges is 200 millimeters and experiencing a 10 Newton force. Find the value of the charges. Okay? Two identical charges ang pinag-uusapan natin. So value of Q1 is equals to value ng Q2. So from our formula, no, that will be K. Pwede natin gawing Q1 squared, R squared. Okay? So given yung distance, ang hanapin natin ay Q1. So, Q1 will be equals to F R squared all over K, then square root natin. Okay? So, derivation lang yun ng formula. If you are having difficulty, i-practice nyo lang um, yung algebraic knowledge, no? Yung algebraic manipulation. Okay? F natin is 10 newtons. R natin is 0.2 meter squared all over. K natin is 9.0 times 10 to the 9 Newton meter squared per Coulomb squared. Okay, then square root natin. So, Newton is cancelled out, meter squared cancel out. Pupunta si Coulomb squared sa numerator, then lalabas siya dun. So, makukuha natin si Q1, which is, ang value natin is 6.67 times 10 to the negative 6 coulombs or 6.67 micro coulombs. Yan yung value ng Q1 and Q2 natin. Okay? So, don't forget yung ating exponent or yung unit natin dapat tama, no? Kapag ang nalagay nyo is 6.67 coulombs, that is incorrect. Halimbawa, 6.67 times 10 to the 6 coulomb, that is incorrect. So, be careful sa sign ng exponent and sa pag-convert ng prefixes natin sa mga ano natin. Okay? So, yun lang yung note natin. Okay, so that's for number 4. Then next, last number for Coulomb's law. Okay. What separation distance is required if the attractive force between an electron and a proton is 50 newtons? Okay. So, okay, attractive force. So, ano bang indication na attractive yung force natin? Kapag yung value natin is negative, no? Kasi yung electron natin, pag negatively charged yung particle natin, automatic negative yung value niya. Okay? So let's say dito yung electron and proton yung pinag-uusapan natin. Anong value ng charges natin? Charge ng electron and charge ng proton, charge ng electron. Anong value natin?
1.6 times
Okay?
10 raised to
Okay,
negative
so
19.
kanina 1.6. Thank you, Ms. Robillosa. times 10 to the negative 19 ba? I'm not sure. Wait. Tama ba? 19? Uh, Let me check para di tayo pa ulit-ulit. Okay. Saan yan? Yes. Negative 19. Tama na yan. Coulombs. Okay. So, kay proton positive, pero kay electron ay negative yung value niya. Okay? And then, pagkuha natin ng F, no? K, Q1, Q2, all over R squared. So, attractive force yan. So, dapat pag sinubstitute natin si 50 Newton dun sa F, dapat may negative value tayo. Okay? So, ang hinanap natin is yung distance ulit. So, yung formula lang natin, same as kanina sa number 2, I think. No? Over F, tas square root. Okay? Then, substituting this value, R is equals to K natin, 9.0 times 10 to the 9 Newton meter squared, Coulomb squared. Then, sa proton natin, 1.6 times 10 to the negative 19. Sa electron natin, negative 1.6 times 10 to the negative 19. Then, over yung force natin, negative 50 Newton. Okay? Again, nag-negative tayo ng sign kasi attractive yung force. Kasi ni-negative din natin yung value ng electric charge dito. Okay? So, mangyari lang naman sa kanya, magka-cancel out lang siya. No? Kailangan lang natin pakita na magpa-positive siya kasi nasa loob siya ng square root uh, na symbol. No? And we can't have a negative value inside the square root. No? Kasi magiging siyang imaginary number. Okay? So, ano yung value ng R natin ngayon? So, yung Newton will be canceled out. Coulomb. No? So, yung dalawa, Coulomb. Makaka-cancel out siya. So, ano yung value natin? Okay. 2.15 times 10 to the negative 15 meters. Ano yung 10 to the negative 15? So, sa hindi nakakalam siya, ang equivalent niya ay anong tawag sa kanya? Femto, no? Pero baka sa choices hindi na naman niya pinahirapan, no? So itong F na to is pertaining sa femto. Tama ba? Femto. Let me check nga kung tama ang aking mali pala. Walang P. Okay? So femto. Okay? So yeah. So na negative 50. Okay? So question regarding Coulomb's law.
Sir, ano po ibig sabihin yung femto, sir?
Femto ibig sabihin times 10 to the negative 15. Para din siya katulad ng micro, pero imbis na negative 6 yung exponent, negative 15.
So, pwede na rin po yung times 10 to negative 15 na lang po, sir.
Okay na din naman yung negative 15. Ang inano ko lang is kapag halimbawa kasi sa makita nyo sa choices, halimbawa sa qualifying exam, kung lumabas yung ganyan sa qualifying, no? Tapos wala naman yung sa choices yung negative 15, ang nakalagay is, nilagay niya is nano, micro, femto, tsaka milli. Alin yung ano yun doon, no?
Okay po, thank
Kaya
you po.
binax ko siya ng isa, no? Lahat ba may ganong unit? Kung hindi siya lagi ginagamit, no? Kasi masyadong maliit na scale siya. Siguro kung more on chemical engineering yung course mo, siguro yung mga microbiologists natin, mas nagagamit siguro yung mga ganong unit. Pero tayo, usually hindi na natin ginagamit yung ganong unit, no? Pinakita ko lang na yung negative 15 ay femto. Okay? Pero kapag sa engineering, yung scientific notation na times 10 to the negative 15 is already acceptable naman. Okay? Okay, question muna before we proceed sa next topic. Okay na tayo? Thumbs up kung okay na. Okay na. Okay, thank you. Okay. Now, we will now proceed dun sa pag-differentiate nung tatlong components natin. But before we go back, but first, let us first go back dun sa electricity natin. No? So, sa electricity daw is a flow of electrons around a circuit. Okay? So, yung circuit natin, ayan, yan yung example ng circuit natin. So, tinatawag na electrical circuit ang isang system kapag siya ay merong mga components na yan, nakalagay na yan. So, later, discuss natin yung electrical circuit. Pero, ito muna, the current o yung flow ng electrons is defined as the rate of charge movement or movement of electrons to an area over a given amount of time. Okay, itong current na to is pertaining dun sa ion natin. So later meron tayong separate na in-depth definition yan. Okay? So ang sabi, yung the faster the movement of electrons, the higher the current. So kung mas mabilis ang daloy, no? Syempre mas mataas ang current. Sabihin, many charges are flowing kapag mas mabilis yung movement natin. Okay? Then we have yung conductors and insulators natin. So, nadaanan ko na din to dun sa thermal expansion topic natin last phase, no? So, pag sinabi conductors, inaalaw lang niya yung electrons natin to flow easily. So, example of conductors are copper, aluminum, silver, gold, no? Are some metals that are good conductors. Then, tatawag natin insulators. Sila naman yung hindi nag-aalaw ng easy flow of electrons. Okay? Materials such as glass, plastic, rubber, and paper are good insulators. Okay. Then, let's go back to sa electrical circuit na tinatawag natin. So, ang isang system, tinatawag natin electrical circuit if it has the following components. Ang tatawag nating source, controlling device, conductor, tsaka load. Okay? So, ano yung source? Yung source natin is yung source of charge natin, ng energy natin. Okay? So, dito, yung battery natin, single dry cell. Okay? So, yan yung source natin. Controlling device, so ibig sabihin, siya yung nagper-permit ng allow, no? Nag-a-allow ng flow. So, dito yung switch, yung controlling device natin. And then conductor natin is yung wires natin. So ibig sabihin yung material na ginamit dun sa wires natin are good conductors or they let the flow of electrons move easily, no? Then yung load natin is yung light bulb natin na magko-convert nung energy na galing dun sa dry cell sa battery natin into another form. So let's say or heat or light energy. Okay? So yun yung bumubuo sa electrical circuit natin. Then we have yung properties ng electrical circuit na ito yung main three components sa properties na mahalaga sa kanya. Yung voltage, current, and resistance. So, ang mga units niya tinatawag na volts, amps, tsaka ohms. And in symbol or yung unit niya in symbol is V for volts, A for amperes, so amps, then omega for ohms. Okay? So, discuss natin isa-isa yung bawat properties na yan. So let us first go sa current. Okay? So current, usually designated as the letter I, no? Is compare natin ngayon sa mas madali kasi yung i-idealize natin siya sa mas madaling system, no? So let's say sa isang tank na merong connected na pipe, then may faucet sa end, then ililet natin mag-flow yung water, no? Sa current, pagko-compare natin dito sa system natin na visualization, si current daw is yung flow, no? Siya yung dinidescribe niya yung flow ng electric charge dun sa buong system natin. So kung sa circuit natin, si current is yung sa flow ng electric charge. Okay? So, ibig sabihin kapag halimbawa yung switch natin, bawa yung sa faucet natin, kung tubig yung pinag-uusapan natin. Kung sarado ang faucet natin, yung water natin is hindi siya magfo-flow, no? So, ibig sabihin, kung sarado ang switch, so bawa switch is naka-off yung switch, bawa sa isang circuit, kapag naka-off yung switch, hindi mag-flow yung electric charge natin within dun sa system natin. Okay, dun sa wirings natin. Then kapag in-on natin, halimbawa dito sa system natin dito, binuhay natin yung faucet natin, ang mangyayari is dadaloy na yung tubig natin. So yung daloy ng tubig, idealization again, no? Ibig sabihin, para mas madali natin ma-visualize kung ibig sabihin ng current. Kasi sa tunay na buhay, hindi natin makita sa current. Eh. Okay? So, basta si current is pertaining dun sa flow ng electric charge natin. Okay? Then, these are the some of the properties ng current. So, yung measure daw niya is amount ng electric charge transferred per unit of time. So, current daw, no, is the measure amount ng electric charge, no? Electric charge natin is Q, then transferred per unit time. Okay. Kaya, ito yung formula na ginamit sa kanya. Okay? Then, yung SI unit na ginagamit sa kanya is ampere or yung simply A nga yung tawag natin. And then, 1 ampere daw, okay? 1 ampere is equals to 1 coulomb per second. Okay? So, ibig sabihin, pag nakakita ka ng ampere na unit, pwede mo din siyang ilagay as coulomb per second. Okay? So, it was named, yung ampere na unit is named after Andre Marie Ampere. Then, yung formula again is I is equals to Q over T, where Q is yung charge natin in coulombs, T is equals to time in seconds, and I is equals to ampere. Again, coulomb per second is equivalent to ampere. Okay? Then we have example problems para sa current. So, madali lang to, no? So, simple problems for current. So, first one, if 10 coulomb of charge passes a specified point in 2 seconds, how much current is flowing? So, direct substitution lang, no? 10 coulomb over 2 seconds is equals to 5 coulomb per second, or as we say, coulomb per second is equivalent to 5 to amperes. So, ibig sabihin 5 amperes. So, ito yung answer natin. Okay? Next. If a current of 5 amperes flows for 2 minutes, find the quantity of charge transferred. Okay? So, pinapanap naman is si Q. So, pang Q ang hanapin, ang formula natin is I times T. Then, yung I natin is 5 amperes of 5 coulomb per second. Then, 2 minutes yung time natin. So, dapat convert natin into seconds, no? So, 1 minute, sa isang minuto, merong 60 seconds. So, convert lang natin. So, ilan? So, 5 times 2, 10 times 60. We have 600 columns. Okay? So, 600 columns yung quantity of charge natin. Okay? Last, number 3. In what time would a current of 1 ampere transfer a charge of 30 columns? Okay? So, pag si time, our formula will be Q over I. So, this will be charge natin is 30C over 1 ampere, so 1 coulomb per second. So, yung time it take to transfer a current of 1 unit is 30 seconds. Okay? So again, these examples are only simple examples. So in our next discussion next week, we will be incorporating some laws na nagko-correlate doon sa ibang mga properties with each other. Okay? Basta ngayon, alam natin na kapag current pinag-uusapan, ito yung unit niya, ampere, na equals din siya sa coulombs per second. And yung relationship ng charge and time is yan, para makuha natin yung current natin. Okay? So, any question para sa current? Okay. Next, now we go to sa voltage natin or in symbol V. Okay? So, balik tayo dun sa idealization natin. Si V, si voltage, pwede natin siyang i-compare as yung pressure, no? Na nagkakos nung flow ng current natin. Okay? So, ibig sabihin, kung halimbawa sa tubig yung pag-usapan natin, kapag sarado yung gripo, ano yung papansin nyo na-try nyo na? Pag tinry nyo yung i-fill yung tubo, yung mismong faucet, kahit sarado siya, nararamdaman nyo yung vibration, no? Ng tubig. Kasi si pressure, patuloy niyang gustong ah i i-utilize yung flow ng tubig. Kaso walang outlet o walang paglalabasan ng water. Kaya nangyayari yung pressure, no? Continuous lang yung pag-apply niya. Ba, ganun si voltage. Continuously ina-apply niya yung sa switch yung 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 puwersa niya para dumalo yung current, pero since naka-off ang switch, hindi magfo-flow yan. Okay? Then kapag halimbawa inopen natin siya, of course yung pressure natin will push yung current natin para gumalaw yung electrodes natin in the electric circuit. Okay? Then, ito yung ibang other facts about volts or voltage. So, voltage is the electrical pressure or force na tinatawag din natin electromotive force, okay, or EMF. Sometimes, tinatawag din siyang potential difference. Okay? Then, the unit of measured voltage is volts. Okay? Na sometimes, ang ginagamit na symbol is V or E, no? Especially kapag circuits na yung pag-uusapan, usually E yung value. Especially sa mga battery, yung source, yung voltage natin ay E ang value. Okay? Si volts is named after Alessandro Volta. Then, ang sabi, si volt is equals to 1 joule per coulomb. No? So, ibig sabihin, yung 1V is equals to 1 joule per coulomb. Or sa formula natin, energy over charge. No? So, W over Q. Okay. So, that's also applies sa sample problem. So, ulitin lang natin, volts is equals to energy over charge. Okay? Number one, how much voltage is needed to move 20 coulomb charge with 100 joules of energy? So, direct substitution. We have 100 joules all over 20 coulombs. So, we have 5 J over C or joules per coulomb or 5 volts. Kahit 5V na lang. Okay? Next, potential difference. So, ibig sabihin yung voltage natin exists between 2 points A and B within an electrical field. What is the magnitude of the charge that requires 5.5 millijoules of work to move it from A to B? Okay? So, ang pinapahanap is magnitude of charge. So, yung Q natin. So, Q natin is equals to W over V. So, convert lang natin into standard unit. So, yung 5.5 millijoule natin equals sa times 10 to the negative 3 joule. All over yung voltage natin na 10 volts. Okay? Again, sa 10 volts, pwede natin i-represent as joules per coulomb. No? Kaya magka-cancel out yung joules. Pupunta sa coulomb sa taas. So, yung unit natin will be 5.5 times 10 to the negative 4 coulombs. Okay? So, yan yung answer natin for number 2. Okay, next. Number 3. A battery does 6 joules of work every 4 coulombs of charge that it counters every 2-second time period. What is the voltage of the battery? So, volts equals to energy over charge. So, yung energy natin is 6 joules. Then, charge natin is 4C. So, we have 1.5 joules per coulomb is volts. No? So, yan yung voltage ng battery natin. So, si time is hindi natin kailangan kasi hindi naman pinapanap sa atin yung current ng problem. No? Okay? So, question po para sa voltage. Meron ba?
Wala po.
Okay, thank you. Okay. Last is na natawag nating resistance, no? Or yung symbol ng ano niya is ohms. Okay? So si resistance naman daw kung ilalagay natin sa idealization natin. So ito yung mga oppositions do sa current flow natin. So kung halimbawa sa daloy ng tubig sa pipe natin, pwedeng ang representation niyan is si resistance is yung mga impurities na meron tayo sa pipe natin. So halimbawa meron tayong mga pebbles, no, dun sa pipe natin. Okay? So kapag pinush ni voltage si current, no, kung may mga batong nakaharang sa kanya, ang tendency niya is ano, i-decrease yung flow. Okay? So, yun yung ginagawa ni resistance. Kaya resistance. Okay? Resist. So, ino-oppose niya yung current flow. So, kapag dumaan siya ngayon, dun sa resistance natin, ang nangyayari dun sa current natin is nagde-decrease siya ng value. Okay? So, same din sa electrical circuit natin. Ganon din yan. Okay? Then, ito yung other characteristic niya. So, again, property siya ng material na nag-oppose or resist ng flow ng charge through it. Then yung unit of measure ng resistance is ohms. Named after George Simon Ohm. And yung resistance symbol is yan, yung mukhang kidlat, no? Then resistance depends on the type of material, length, cross-sectional area, and temperature. Okay? So ito yung mga kung saan siya uh, dependent. Okay? So yung rho dito is yung material resistivity natin. So usually given as constant yan. So may specific value yan for each material. Kapag hindi given sa problem, may table tayong pwedeng pagkunan. Okay? Then cross-sectional area. So dito sa formula natin, this is ohms meter, yung delta natin. Then yung length natin is meter, then yung area natin is meter squared. Cancel yung meter squared, matitira is ohms, kaya resistance yung magiging sagot natin. Okay? Okay. So ito lang yung um, kung kailan nagiging lesser and greater yung value ng resistance. So tingnan nyo lang tong formula, no? Sa formula makikita nyo, yung L is nasa numerator. So ibig sabihin, pag lumiit yung value ni length o mikli si length, maliit lang din yung value ni R. Pag lumaki si L, si length, malaki yung value ni R. No? So ibig sabihin, pag sila na pag-usapan, the shorter the length, the smaller the resistance, the longer the length, the larger the resistance. Okay, the greater the resistance. Ngayon, kay area naman baliktad. Nasa denominator siya ng formula. So, ibig sabihin, pag lumiit yung area natin, ang mangyayari, mas lalaki yung resistance natin. Okay? And pag lumaki yung area, liliit naman yung resistance natin kasi dinidivide natin sa A. Kung malaki yung value ng A, liliit yung value ng resistance natin. Okay? Kaya ibig sabihin, pag mas malaki ang area ng wire natin, no? Mas less ang resistance, mas mabilis. Pag mas malaki ang area ng wire natin, mas maliit ang resistance, tapos mas mabilis ang flow ng current natin, no? Kaya mapapansin nyo kapag mga heavy duty na electrical equipment, no? Di na pwede yung basta-basta maninipis na wiring lang o extension lang, no? Kailangan mas makapal para mas mabilis ang daloy ng current, no? So, yun ang ibig sabihin nun. Yun yung relationship nitong dalawa. And sa material naman, less resistance siya. Maliit ang resistance kapag kapag conductor yung material natin. Let's say copper yung material natin. Okay? Then greater ang resistance kung insulator ang gagamitin natin. Okay? Sa temperature, the lower the temperature, the lower the resistance. And kapag mas mainit yung surrounding, mas mataas yung resistance. Okay? So, kaya pala pagdating sa mga nasasakop ng kasel ko, no? Sa mga, di ba ilang linggo na kayo laging brown out kasi nabalita ko sa kasel ko laging brown out pag weekends or holiday, no? Kasi di ba mainit ngayon sa ibang parts ng Quezon, no? Tapos kung ano pa, laging nawawala ng kuryente, no? Humihina ang kuryente lagi. Kung di man brown out sa inyo, mahina ang kuryente. Okay? So, baka dahil sa ganito, no? Sa yung resistance natin kasi mainit, mas mataas yung resistance, so yung flow ng electricity is mahina dun sa area natin. Okay? So, ito yung tatawag natin kaninang material resistivity table. Ito yung delta natin kanina. So, ito yung mga value natin na constant na no need naman to memorize. Pero if ever hindi given sa problem, you can always go back to this slide. Okay? To get this value. Okay? Kung wala pa dito yung binigay na material sa problem, try to search sa internet, no? Kung meron ng value. More or less, kakalapit lang naman yung value nung makukuha natin sa internet kung magkaiba man ang reference. Okay? So, sample problem tayo with regards sa resistance. Again, yung formula natin for resistance is Rho times L over area. Okay? What is the resistance of a 30 meter length copper wire with a diameter of 2.0 mm? Okay? So, first, hanapin natin yung resistivity natin. Ang material natin is copper. Copper natin is 1.68. So 1.68 times 10 to the negative 8 ohm meter. Length natin is kailangan in terms ni meter, no? So 30 meters, so okay na. Then yung area natin, so area ang hinahanap. So may diameter tayo. So ano ibig sabihin ng diameter? Ibig sabihin yung cross-sectional area natin is a circle. Area ng circle is pi over 4 diameter squared. So substitute natin with convert na natin yung mm to meter, no? Okay? So, yun yung magiging value niya. I-direct ko nang i-substitute dun sa formula, no? Para isang compute na lang. So, R is equals to 1.68 times 10 to the negative 8 ohm meter times yung length natin na 30 meters all over yung area natin pi over 4.002 meter okay, squared. So, yung meter natin, magka-cancel out. Matitira is ohms na lang na may value na ilan. May mga nahirapan pagpindot dito, no? Yung tamang pagpindot. Pag may mga fraction na sa ilalim, anong value na kukuha nyo? Okay, correct. Mr. Pagkatipunan, Mr. Aman. Okay, 0 point. Okay, Mr. Villosa. Okay, Mr. Chensa, Paninya. Miss Pable, please uh, ano yung pindot, no? Paayos ng pindot. Baka may namaling pindot lang. Okay, so 0.1604. Okay, so ito yung correct. Okay, Mr. Kito. Okay, so ito yung value natin for number 1. Okay, next, number 2. Okay, so again, yung mga problem natin, more on substitution lang directly, no? Walang ka-challenge. Pindot lang ang challenge na. Okay? So again, next meeting, I'll give you a more challenging set of questions na i-solve natin uh, sabay-sabay para mas alam nyo kung paano i-analyze yung problem. Okay? Okay, next. 500 millimeter length of wire with a cross-sectional area is to have a resistance of 2.53 times 10 to the negative 3 ohms. According to the resistivity table, from what material is the wire made? Okay? So, meron tayong given L. Ito yung L natin. Cross-sectional area A. Ito yung R natin. So, delta yung wala natin. So, si delta makukuha natin by R times A over L. Okay? Substitute. We have yung R natin is 2.53 times 10 to the negative 3 ohms. Area is 3.14 times 10 to the negative 6 meters squared. All over yung length natin na 0.5 meters. Okay? Cancel yung isang meter. Matitira is ohm meter. Okay? Ano yung value niyan? 3.14 negative 6 over 0.5. So 1 point. Paayos ulit ng ano. Okay? Baka ano lang yung sulat ko, no? Yeah. Okay. Correct me sa Chensa. 1.588. Kompletuhin ko lang, no? 4 times 10 to the negative 8 ohm meter. Okay? So, kung yan yung value nung ano natin, nung resistivity nung material natin, mula dito sa table, 1.588 o 1.59, ano siya? So, siya ay silver.
Silver.
Okay? So, therefore, siya ay silver. Okay? Question regarding resistance. Okay? Wala na?
Ano po?
Okay? So, kung if you don't have any more question, this ends our lecture for today. So, ito lang as last illustration lang natin. So, yan nakikita natin si volt, pinupush niya si ampere, no? Pero si resistance, pinipigilan niya makapasok si ampere. Okay? So, yun lang yung lagi yung i-visualize kapag pinag-uusapan yung tatlong yan. Okay? Next meeting, we will be discussing yung relationship ng tatlo and how we can intercorrelate yung tatlong yan. So, meron tayong formulang ginagamit para mahanap yung value ng volts kapag given ang resistance sa ampere. Same as kung pag nawawala yung ampere, makukuha natin yung pag wala yung ampere, tas given yung volts and ohms, pag given yung volt and ampere, makukuha natin yung ohms. Okay? So next meeting, discuss natin yan. But for now, this ends our lecture for today. Okay?
Sir, pabalik nga po dun sa last problem. Maititingnan lang.
Okay?
Okay na po. Thank you.
Okay. Thank you. Okay. Okay. So this ends our lecture for today.